Chapter 10, Problem 7. We have this spinning wheel with 8 spokes. It's mounted on a fixed axle and is spinning at 2.5 revolutions per second. We're going to shoot a 20 centimeter long arrow parallel to the axis through the wheel without hitting any of the spokes. Assume the arrow and the spokes are very thin, i.e. there's no thickness to anything here that we have to take into account. What minimum speed must the arrow have? Okay, so the real question is, how long does it take for this wheel to go through an eighth of a revolution, right? So the amount of time we have at 2.5 revolutions per second, the amount of time we have is second per 2.5 revolutions times 0.125, or 1/8 of a revolution, right? That's how long we have to get the arrow through. All right? The time it takes to make one revolution, right, is the inverse of the rate. Let me back up a second, and we can just say theta equals omega t, right? And we want theta equal to 1/8 of a revolution, and so we get t equals 1/8 revolution times 1 over omega, which is 2.5 rev per second. Yep. Okay, that's the formal math for how I got to where I got real quickly there. And so we have 0.125 divided by 2.5. Where did I put an A? Oh, I stuck a negative in at the beginning. Okay. So we have 0.05 seconds. 0.05 seconds to get the arrow through. So the arrow is what minimum speed must the arrow have? All right, the arrow is the velocity of the arrow needs to be its length divided by the amount of time we have, right? And so 0.2 meters divided by 0.05 seconds, 0.2 meters divided by 0.05, and so the arrow needs to be going at least 4 meters per second to make it through. Now, part B. Does it matter where between the axle and the rim of the wheel you aim? If so, what is the best location? The answer is it does not matter. Why doesn't it matter? Because we're talking about angular velocity, right? The angular velocities. And so when we look at what happens with this spoke, this wedge, right, between two spokes, well, it takes the same amount of time for this point to go there as it does for this point to go there. So while it may look like we've got more room up here to shoot the arrow through, in fact we don't have more time. We have the same amount of time no matter where we shoot the arrow as it passes through the spokes. All right, that's it for problem 7.